Now, you might have heard the term big data. So what is big data according to you? So if I ask this question to many people, everyone have their own answer. Some will say if the volume is very huge, it is big data. Some might say that if I'm not able to store the data on my laptop, it is huge for me, right? So we might get many definitions of the word big data. This is a very raw term. However, there is one formal definition which is given by IBM. IBM has given a very formal definition for the same. IBM says any data which can be characterized by three V's is considered to be as big data. Now we need to see what are these three V's as per IBM. And this is a very common definition. Many of you might be aware of it. So IBM says that if any data can be classified or characterized by these three V's stand for volume, variety, and velocity, then it will be called as big data. Now let us try to understand these three V's as per IBM. So with the name volume, it is very clear that the volume of data should be huge. That means it should be few terabytes, few petabytes like that. It's not small data. That means a single machine should be incapable of handling that. The volume is so huge. The name specifies it all. Now, if we talk about variety, variety says that data can be in different types. It can be structured, unstructured, semi-structured. It's not like traditional RDBMS systems or traditional SQL systems where we get the data in a structured format only. We have to handle unstructured plus semi-structured data also, right? So let's first talk about volume. You can see that the volume of data can be really huge, which our traditional systems cannot handle. You can see this, right? 2.5 quintillion, right? So it's very huge. Kind of with the traditional systems, we cannot even imagine to handle this much of load of data. So with variety, we have structured, semi-structured, and unstructured. So when we talk about structured data, the examples can be your RDBMS databases like Oracle, MySQL, or any other database. Semi-structured can be your CSVs, XMLs, and JSONs, right? You know that these have partial schema associated, not completely and not, I mean, it's not totally unstructured also, but a partial schema is associated with the CSVs, XMLs, and JSONs. That's why it is coming under category of semi-structured. Now, unstructured basically means your videos, your audios, even your log files. For example, if a web server is giving any logs, now, does that have any schema? No. So that is unstructured. So using our big data systems, we need to handle all these kinds of data. It's not just the structured data we need to handle. We have to handle all three kinds. Now comes velocity. So velocity basically refers to the speed at which new data is coming in. For example, let's consider that you are already handling 1 terabyte of data. But what about new data that is coming in with an increased pace? Can you discard that? No, not at all. Because all the data is very important. You cannot discard any piece of it. Consider an example of Flipkart Big Billion Day. Don't you feel the velocity will be really high during those days compared to the normal days? Because someone like me, I mean, never bothers to buy something. I'm even tempted to see what is the sale going on and let me make a transaction during that day. So the velocity will be higher on some days and velocity might be low on some days, but the system should tackle that. So these are the three V's as per IBM: volume, variety, and velocity. If any data is characterized by these three V's, it is called as big data as per IBM. However, there are many variants of this formal definition floating on the internet. For example, you might see a definition with 4 V's, 5 V's, 7 V's, 11 V's. Now, we cannot go so theoretically, rather, our approach should be practical. Right? So 4 V's is still somewhat relevant. So let me just talk about it. What is the fourth V? The fourth V stands for veracity. Many of you might have heard about the three V's, but fourth V or the term veracity might be new to you. So let us talk about what is veracity. So veracity refers to the nature of the data. where we say data has poor quality. Let's say you have some data. There might be a lot of null values, a lot of missing values. Age might be negative. There can be n number of quality issues. And this is what is referred as veracity. So veracity refers to the nature of the data where we say data is not clean. It is unclean. So poor quality data, unclean data. That means in big data systems, do not expect that you have high quality data. Your data might have poor quality and you might have to handle that. So we have talked about the 4 V's of big data as per IBM. Volume, which stands for really huge amount of data which traditional systems cannot handle. Variety, which means that we just do not have to handle structured data, rather we have to handle unstructured and semi-structured also. And third one was velocity, which refers to the speed at which new data is coming in. We need to tackle that. If the speed is high, we have to adopt to it. And fourth V is veracity, which refers to saying that the data has poor quality and we need to tackle it. Do not feel that data will be in the form which is desired. Data might not be in the desired form. Now, these are the 4 V's as per IBM, and this is one of the formal definitions, so I thought of letting you know. Now, everyone is tempted to learn big data technology. I understand we learn this in order to upgrade our career, to get new jobs, better hikes, and all. Fine. But what is the business goal that you are trying to solve using this? Try to think that. So what there should be a problem statement you are solving by learning a particular technology. What is that problem statement? So just think of one line problem statement that you are trying to solve by learning this big data technology. So if you ask me what is the whole purpose of learning big data, it is just one purpose, that you will be able to process or you will be able to crunch huge amount of data which you cannot do using the traditional systems. There is nothing more than this. You want to process huge amount of data which your traditional systems were not capable of doing. As simple as that. Right? So the requirement is very clear that why you are using or learning all these big data technologies is you want to process huge amount of data which traditional systems cannot do. Now I understood that traditional systems cannot process huge amount of data. But don't you feel before this there is a prerequisite? The prerequisite before processing is storage. That means if my traditional systems cannot process, they cannot store also. I mean, if I have, let's say, a laptop with 1 TB hard disk, and I am getting a data of, let's say, 1000 terabytes. Can I store this 1000 terabyte data on one laptop? No, because my laptop is capable to handle 1 terabyte only, let's say. Then how can I store this 1000 terabytes on a single machine? That means my traditional systems cannot even store the data because data is so huge that it cannot be stored on a single machine. So before thinking about processing, we need to worry about storage because our traditional systems cannot even store huge amount of data. We need a different system, right? So to process huge amount of data, first need to store it. So before worrying about processing, let's worry about storage, because first you need to store and then you think about processing, because it's a step-by-step procedure. You cannot first process and think of storing, right? The data should be kept somewhere. So first your worry should be you want to store it in a very nice manner somewhere, and then you want to process it once the data is stored properly. So first storage and then processing. So are our traditional systems capable to store such massive amount of data? No, not at all, right? So traditional systems are not fit to store huge amounts of data, as mentioned. So the first thing, or let's say if someone asks you that, can you design a good big data system? Then the very first thing you need to worry about is storage. That means if someone is referring to big data, how will I store that big data? Because my traditional systems cannot help me out. So the first thing you need to worry about is storage. Store massive amounts of data in a proper way, right? Now, Once storage is tackled, you need to worry about processing, because you have said, okay, my storage is done, let me worry about processing, right? So now you need to worry about processing or a way that you are able to handle this data, right? Now there is a third requirement also, which you might not feel it's intuitive, but it is very, very important. The system should be scalable. That means, let's say today your manager asks you that can you design a system which can handle 500 terabytes of data. Now you have designed a very fancy, beautiful system which can handle 500 terabytes of data. Fine. Tomorrow your manager comes back to you and say that our requirement has increased 10 times. Our requirement has increased 10 times, and instead of 500 terabytes, the requirement is to handle 5000 terabytes, 10 times. Now you cannot wave your hands and say, boss, you gave me a wrong requirement. No, you cannot do that. You cannot afford doing that, because this is IT where the requirements keep on growing. You have to tackle that. That means with the changes or with the growing needs, your system should adopt. If the requirement increase, you need to make sure you are able to accommodate that somehow. If you are able to accommodate the growing demands, then it is called as a scalable system. If you are not able to do that, then it is not scalable. So you need to make sure a good big data system is always scalable so that it can adopt based on the growing needs. Because if it is not scalable, then this system might work today, but not tomorrow. So I hope I am clear with this. So basically, there are three things you need to think of when designing a good big data system. Storage, because your traditional systems cannot store the data in a proper way. Processing, because your traditional systems cannot process it. And third is scalability. That means if the requirement grows, you need to tackle it in a very efficient way. So store, process, and scale. These are the three things required to design a good big data system. You can just have a look at this slide. It should give you a clear picture. Now, why we are not able to store and process? Because data is so big. We are not able to store it, I mean, in a single machine somehow. Okay. Now, let us come to this thing. Here, storage and processing seems to be very easy and intuitive to understand. Scalability might be a little confusing. That is why I have some more content around it. Now, when we talk about scalability, it's a good point to talk that a system can be designed ideally in two styles, or there are two ways to design a system: monolithic system and a distributed system. You might have heard or read it during your academics and all. Now let us try to understand what is monolithic and what is distributed.